Hello everyone, any questions before we start? So today we are going to start writing some SQL queries. So your project design stage number 1 is graded and you have the feedback on Moodle. So if you received full mark, then there is no feedback. But otherwise there is some feedback, and for the next stage we expect you to first make some corrections in the ER diagram. Then we want you to write the relational schema for your database. And the relational schema was the topic of the previous lab. So we have this relational schema example, and in the lab slides as well, you have example cases for example, for aggregate relationships, for different kinds of cardinality, etc. So what you are going to do for the design stage 2 is such a document. So this is the example for the ER diagram that we gave in lab number 1. And you are going to do this for your project topic. Any other questions or problems about the project? So actually it's a relatively simple stage of the project. And like, don't leave it for the last minute, because we have the exam next week, so the due dates are kind of crowded because of the summer school, but the due dates for this stage is next week on Friday night. So this step should not take like more than an hour. So as a group, actually, if you divide it, it is going to take even less. So coming back to here,
Can I say something?
Sure, yes.
About the project. Do we need to convert it into a database in SQLite?
It is going to be in implementation stage 1. So for now, you just create a document, the relational schema. You just describe the attributes, the foreign keys and primary keys, and that's going to be it for this stage. And later on we have, so let me come back to here. So for the implementation stage 1, you are going to create it later on, and then you are going to have some Python code to create the graphical user interface. But for this design stage number 2, it is just the design. It's just a Word or PDF file.
Okay, thank you.
No problem. So you actually don't need to hurry about like starting the code. We have like individual stages for each of these. In implementation stage 1, you are going to create the SQL database this time. Remember, we were using SQL Studio, so I'm going to actually open the program. So you will have time to create your database using SQL Studio. Then we are going to go into Python. We will start writing some code to interact with the database, and for each of them we will have some labs and also some detailed examples. So for this lab, if you want to follow along, what we are going to do is we would like to write some SQL queries, and for that we have this SQL database. This is an example database. It's a very simple one, but if you download that one, we need to open it up in Sql Studio. So the way to do that was, we need to go through the database section, and we are going to add a new database. So this time we would like to open an existing database, so we click on this button, and this file was named as lab3.db. so I'm going to actually locate that file, open it up, and this is going to be the name in the program. Then we have this database. Let me actually close all other things. So let's say we don't know anything about this database, the structure of it. When we open it up, we will see the tables of it, right? So in this lab3 database, we have 3 tables actually. They are company, partner of, and user tables. And for example, let's start with the user table. If you double click on the table name, it will bring the description or the structure of that database. So in here, actually, we have ID, right? This is the primary key. So we can see or get the information from the structure. So for these 6 attributes, they are required. We cannot have null values for them. But for the city attribute, it can have null values. We have this partner of, or maybe let's start with the company. In the company, we have the company ID. It's the primary key. So we have like other kinds of attributes, company name, monthly payment, and in the user table, if you would like to see the data of it, so I double click on the user table, then I can go to the data section, and in here I see the entries of the user table. For example, there is for user ID 1 we have William, so the credit is the amount of credit that this user has. There is the status, there is date of birth, and for some of the users we have the city information, but it's not required, yeah, right? So we can have null values there as well. So we also have the partner of table, and since we have foreign keys, you might realize that this is kind of a relation between company and user tables. And if you look at it here, we will see that there is a table primary key for this table. So in the user table, what we had was one of the attributes was the primary key. It was the ID. But if you look at the partner of table, we have multiple attributes that contribute to the primary key. So that's the table primary key. To add a table primary key, we were using this button. Then this is a relationship. Why? Because we are using some foreign keys. To get more information about the foreign key, I need to double click on the attribute and go through the configure button of the foreign key. Here I will see that this is a foreign key to the user table, and it is going to actually, the foreign column is ID. So the user ID in this table is going to reference the user's ID in that foreign table. So the similar thing for the company ID. This time this refers to the CID in the company table. So these are like, let's say if we do not know the design of this database, we can open it up and like get the information out of the structure. And now we would like to write some SQL queries. So why do we use SQL queries? To extract information from the database in a relational manner, or we can also update, insert, or delete our entries using SQL queries. And in SQL Studio, to write an SQL query, we should go through Tools, and then we have this Open SQL Editor option. Another button that we can use is this one, or Alt-E hotkey is the hotkey for getting into the SQL view. So in here, actually we are currently connected on multiple databases. So there are like, we can open up multiple databases right in here. We can connect them, we can connect multiple databases at the same time. So the one that I'm currently on is going to be selected from this option. So this database selected here is going to be the database that I'm running the SQL queries. So if you get any, like for example, if you get any problems saying that we cannot find that table, etc., you should first check that the current database, the active database, is the correct one. So you can always disconnect from the databases that you are not working on. So if I disconnect from all of these databases that are open in the program, then I can only run the queries in lab3. So this is also the same for example, coming back to my table. So if I were to create a new table, so this was the option, right? While creating a new table, it is also listing the multiple databases that are open. So just be careful when you are creating tables, and like if you have multiple databases that are loaded, to work on the correct one. So now I'm going into this SQL editor, and in here I can write SQL code. So the most simple one would be to select everything from one of the tables, and the table names are here listed. So let me also show the columns. So let's say I'm going to select everything from the user table. So I write my query, and in SQL the uppercase letters are conventionally used for the special keywords, but there is no actually requirement for that. So I can just write it like this. So select everything from user table, and to run this query, this is going to be the button, execute query, or the F9 hotkey can be also used. This is going to execute the query, and in the below area I see the results of the projection. As a convention, most of the time we write the keywords, the special keywords, with all uppercase letters, and to be able to read it in an easier way, we kind of get these keywords most of the time to the to new lines. So this is just a convention, but it makes it more readable for the writer of the code. So we can select everything from the user table, and while going, I'm also going to show some mistakes. For example, if I were to type the user table wrong, what happens? So let's try and see. The status window is here. It is going to show like whether your query succeeded or whether there are any problems with the query. So it says that no such table, user n. User n is not a table in this database. And for example, if let me also get one of the other. So if I were connected to one other table, but this one also has the user, right? So let me make it for the company. So for lab 3, I can project from the company, right? But if I choose a different database which doesn't contain the company table, it is going to also say that on this database called lab 2, there is no such table as company. So it is also important that we are working on the correct database. So that's just one more information. So we can project everything, but most of the time we don't need everything, right? We can get a couple of columns. We can get just one column, so we can project the ID from the user table. To include more than one attribute, we are going to have the comma character between them. So ID and name and surname, for example. Let's project these from the user table. I run, and here are the results. So if you omit the comma character, it's going to actually not work, right? So it displays kinda the attributes in a wrong manner. So to have the attributes separate, we need to include the comma characters in between. What happens if I write the attribute name wrong? This time it is going to say there is no such column. So in the database I'm working, there is no IDY column. So this is one error message that we get from there. Most of the time we would like to not get all the data. So for example, let's say we have millions of users and we would like to put some criteria. So for that we are using the var keyword, right? For any of the attributes, so for the user table we have lots of different attributes, 7 attributes, right? Some of them I can project, but for any of these attributes I can put some rules. I can say, okay, var ID is equal to 7, for example. This is something valid. So the projection is going to only return one user where the ID is exactly equal to 7. By the way, when you run the query, you might see that it is highlighting the whole query, and if you were to highlight some portion of the SQL query and click on this run button, it tries to run that portion, the highlighted portion. So if nothing is highlighted, then it is going to run the whole query. But if some portion is highlighted, then it tries to just execute that portion in Sql Studio, so that is one thing to be careful. Then it is going to give a syntax error, but for subqueries this is going to be useful. So one other thing we can say, okay, greater than 7, we can use the less than character. We can say, okay, less than but equal to, less than and equal to, so then the user with ID 7 is also included. And we also have this special symbol for saying that ID is different than, ID is not equal to 7. So if you run this one, then it is going to show all the users except for the user with ID 7. We can combine multiple conditions. So I can say ID is equal to 4 or ID is equal to 7, for example. This is some other query. And while combining them, I use the OR keyword. One common mistake that people do is, for example, in homeworks, etc., using the AND keyword for the areas that are not applicable. So, for example, we know that ID is a single attribute, and ID cannot be equal to at the same time to 4 and 7. So if I try to run this query, then it's going to return nothing, because none of the IDs are both equal to 4 and 7 at the same time. So that's one thing to be careful. But I can combine different criteria for different columns. For example, I can say, okay, ID should be equal to 4 and perhaps the surname should be equal to some other value. So we are going to do such queries. So we also have the slide set here, so let's also take a look at that. So the most common form for SQL queries is selecting a bunch of attributes from a bunch of tables and with some conditions. And for these conditions, we are not actually just listing them, we are combining the conditions using the OR and AND keywords, right? For numbers, for comparison with numbers, we just directly write the number. But for text and dates, there are some special characters that we need to include. For example, let me go back to the step where we were projecting everything. So for example, I can say I want the name to be equal to Wayne, for example. So I can say my criteria is where name equals to Wayne. So if you write it like that, then it is going to think that Wayne is one of the column or table names, and it's going to say that there is no such column called Wayne, because this should be actually a text. And to say that this thing that I'm giving is a text, we need to include the single quotation marks around the word. So if we run it now, then it is going to return for that one user. And similarly for dates, we are going to use single quotation marks, and the format follows like this. We first write the year, and then the month, and then the day. So for example, coming back to the position where we have no criteria, so let me actually also show the date of birth here. So date of birth is another attribute in the user table, and to say that, okay, I want the so the var condition is going to be for dates of birth to be equal to some value, and that value I need to include it in single quotation marks, and then I'm going to write first the year, and then the month, and then the day. So if I run this query, then I get the result. So we can compare using these different symbols, and this special symbol means not equal to. So to say different than we are using that symbol. We can mix and match using and or keywords, right? For example, from the user table, let's say we would like to define two different credit ranges, and we would like to get the users that are in between 180 and 200, or the users with credit 270 and 300. So we are actually defining two different ranges, and we are combining those ranges together. We are getting the users that either succeed in this condition or the users that succeed in this other condition. So if the user's credit is in none of these ranges, then it is not included. But if it is in just one of these ranges, it is going to be included. We can use parentheses to combine these structures. So the star symbol means that we actually project everything, we get all the values. And this is for the highlighted portion, and if you would like to follow along, we are going to you can download this database from the link or from the website. So we have some example queries. So for example, if the question is going let me also say it like let me also mention this. So for second homework, you are going to get some similar SQL questions, and you need to write the corresponding SQL queries for those questions. So actually they are going to be kind of similar to these examples, and you also see some examples in the class, and in the midterm as well there would be probably some SQL query questions. So what you need to be careful as one of the things is that the format, right? So we need to select a bunch of attributes from some tables and with some where conditions in the basic format. For example, for this question, it is going to say that it's saying find name and credit. So I need to project the name and then the credit attributes of the users. So I need to do something in the user table that have at least 400 credits. So this is a criteria for one of the attributes. So the credit should be larger than or equal to 400. And for this, whether I include the equal sign or not for comparisons, it's not actually a big deal. So at least 400 might mean that include the equal sign or not. So that's actually not something while grading we look into very much. So the second one is saying find name and date of birth of the users born between two different dates. Now we have two different ranges, right? And to do that, we actually have two different ways. We can say, okay, date of birth should be larger than this value, and at the same time it should be less than this value. With dates, the greater or larger values are more recent. So for example, yesterday is going to be less than today's date. So when we go into the feature, the value of the dates are increased. So that's one thing to be careful. So for this date of birth, we actually define two endpoints. It should be larger than this value and less than this value. And there is also the special keyword called between. Using the between keyword, we can directly define these ranges without needing to write the attribute name again. So in this version, we have to write the attribute name multiple times, because otherwise these are just separate conditions, right? Where one condition and then the end keyword, for example, another condition, and each condition should include the attribute names. But between is a special keyword, so these are equivalent. So you might choose to use any one of them. But with the between keyword, you give the attribute name, and then you just give two values listed without needing to write the name of the attributes again. So the other question says find name, surname and city of the users that live in either Ankara, Istanbul or Izmir. So this time we are actually listing a bunch of values. So let me come back to here. So we need to find name, surname and city. So no need for the ID. We would like name, surname and the city information for the users, and we have some criteria. So for now, let's just project everything. So these are the values that we get, and for the city information we actually have some special condition. We are saying, okay, this should be equal to Ankara or Istanbul or Izmir. So this should be equal to Ankara. I can write it like this, or city equal to Izmir, or city equal to Istanbul. But if the list goes on, then I need to write all of these, and each time I also need to include the name of the attribute, right? The name of the attribute that I'm working on. Instead, an easier way is to use the in keyword, and then in parentheses I'm going to give a list of items, and in this case the list of items is a list of texts, right? So each of these are text, so I'm giving a set of texts, and city should be in this subset. So that's going to return the exactly same result, but it makes our lives easier using the in keyword. We can check whether something is null or not. So to do that, for example, find name and surname of the users without a city record. If the question is saying that, then I need to check whether city is equal to null or not. So to do that, we again need to use the is keyword. I can say city is null, or if I'm searching for the opposite, then I can say city is not null. So this is going to return the ones where we have a value for the city. So for each of these users we have a value for the city. If I omit the not keyword there, then this is going to return only the users that have no city information. Any questions or problems so far? So these should be actually some basic queries. So with text we can actually do some additional things. So for example, in most cases, instead of looking for exact matches for a text, we are going to search for some common features about the text. So for example, the question is saying find name, surname and credit of the users whose names start with the letter W or whose surname include the letter O. So we are actually searching for some letters in the text. So we can use two special symbols, and let's actually do it with an example. So coming back to here, let's say we would like to project the name only from the user, and for the name I'm going to include some conditions. So let me first start with the exact match case. So I can say name is equal to Wayne. So this is going to only return for Wayne. For text we can use the keyword like. So it is kind of like equals symbol if you write the text exactly, but if you are using the like keyword, then you are allowed to include some special characters here, and those special characters are the percentage sign. The percentage sign means that any number of any characters can replace this single character. So for example, if I write something like this, name is like a percentage sign, then it is going to include all the names, right? Because for any of them, they include any number of any characters. One other thing I can do here, for example, I can write W, then it is going to search for the names that start with the W, and then following, there can be any number of any characters. So there should be one W at the beginning, then followed by any number of any characters. So if I run this, then I see William and Wayne is here. So for example, let me use the small case W. So this is going to actually, so if I go back to the user table, if I look at the name attributes for text, there is actually, okay, then so actually there is no option to use the case sensitive version. So in SQL Studio, if you are using a text, it is always not case sensitive. So that's one thing. So no need to like think about the non-case sensitive version then. Actually, I close my query. Let me. I actually this time closed it. So let me get it back. So I was selecting name from the user table where name is like W percentage sign. So this is actually not case sensitive. So if you were to like use the create table statements then you have the option for using the case sensitive version for text, but we won't need it for our projects or for this course. So let's also see this underscore character. So it is going to say that this character, this underscore character, can be replaced by any character, but it is going to be only for a single character. So if I use 4 underscore characters, it means that the name should include 4 letters. Which letters? I don't care, but there should be exactly 4 letters. So for example, if I do it for 5, then it is going to only show the ones that include 5 letters in it. I can also include, for example, here I can say it is going to start with P, then followed by 4 underscore characters. So for example, if I write it like that, there is no name starting with P followed by 4 letters. For example, we see this one. I can also combine it using the percentage sign. So there should be 3 characters at least. Then it can be followed by any number of any characters. So if I run this query, then I'm going to see the names. For example, Joe is here because I included 4 underscore characters, and following that there could be any number of any characters, and 0 is also an option. So Joe is here, but if I include 4 underscore characters, I won't see Joe anymore here. But for example, William is here. There are 4 underscore characters, and then will part is matched with those underscores, and these remaining 3 other letters are matched with the percentage sign. And I can, for example, say I want the second letter to be A, for example. That's also an option. We can mix and match different things to look for information about text to compare, but I need to include the keyword like in that case. So that's one thing to be careful. So if I use the equal sign, then it is not going to work, because with the equal sign I'm not allowed to use these special characters anymore. We can also get the distinct values. To do that, we just include the distinct keyword. For example, if I'm looking at the cities that users are living in, select city from the user table, then for each of these users, if they are in some city, I will see duplicate values if they are in the same city. To see the only unique values, what I need to write is the distinct keyword. If I say select distinct city, then it is going to not repeat the same names of the cities. And since null is among the values that I have there, it is going to also appear in here. So for city, null values are okay as well. And since I'm getting the distinct city information, then that is going to also be included in my projection. We can use functions, but while using functions, you need to be careful about one thing. The functions can be used as projection values, or to attributes of projection. So we will see it with examples, but first let's just use one of the functions. So I'm going to select the maximum of the credit attributes. So credit is like the money of the user from the user table. So max function is a function that returns the maximum value for one of the given attributes, and for the given credit attribute the maximum amount is 150. For example, if I were to project the credit values, so I will see the different values of the credit for each of these users, and I see that the maximum one is actually 150. Actually 1050, right? So max is one of the functions that I can use. There is also the min function. It is going to return the minimum value for a given attribute. There is the average function. It returns the average. There is the sum function. It is going to return the sum of all values of the attributes. And result of a function is just one value. So that's one thing to be careful. So for example, if I was writing like this, project the name and credit, this makes sense, right? For each of the users, I'm writing the amount of credit for that user. But if I write like sum of credits here, then in different versions of SQL, so we are using SQL lit, right? There is like different versions, MySQL, etc. In some of them, such query will fail. And in SQL lit Studio, it returns something, but it's actually not very sensible, right? It returns just one row. I have to like project the names of the users, but there is only one user, and it's actually the first user. So if you combine the results of functions with attributes in the projection, actually this is going to be not very meaningful. So if we are projecting attributes, then we should only project attributes. Or if we are going to include functions, then we should like deal with the functions. So this is going to be okay actually. For example, I can get the sum of the credits, get average of the credits. I can still project multiple attributes, but not together with the results of functions. So I can use multiple functions together for projection. But if I include, for example, the surname here, then it's actually not going to project it for all of the users. It's actually going to write it for the first user, and this is not very meaningful in our case. So for example, there is another function called count. So let me actually first show this one. For other attributes, for example, for name, getting the sum is not very meaningful, right? Name contains text values, so one thing to be careful. So these are for the numeric fields. Finding the average of the name doesn't going to make much sense. For date of birth, for example, it's going to get some value, but it's actually like treating the dates in a numeric format. Again, it is not very useful in our use case. So we have the count function as well, and most of the time we use it with the star parameter. It counts the entries as a whole. So there are 20 users in our user table. We can look at the separate attributes, then it is going to look only for one of the columns, for the name column. For each user, since we have name, it's going to return the same value. But for the city attribute, for example, remember, city values can take null values, and then it is not going to count the null values of those entries. So for the count function, if I write some attribute name, then it is going to look for that specific attribute, and it is not going to count the null values of that attribute. It is going to count only the non-empty city values. So one thing to be careful about functions, I said, they are used for projection, but not for conditions directly. Let's say I would like to find the user with the highest credit. So name, surname. I would like to get the name, surname, and the credit amounts from the user table, and my condition is going to be for this user's credit to be equal to the maximum credits. So let's just get this one first. I can look at the credits. I see this user with credit 1050 is the one who gets the most credits, and with my var condition I actually would like to specify some condition for the credit, but I cannot do this. So this is not going to work because the functions cannot be used inside the var statements directly. So if I try to run this, it is going to give an error. It's going to say misuse of aggregate function max. So the function max cannot be used as a criteria. So this function max is not going to return the value that I want, because while looking at the user table, this where condition is going to work on the entries one by one, and for an individual entry it doesn't make sense to look at the maximum credit. So if I write credit is equal to credit, again this doesn't make sense, right? For each of these separate entries, the credit is going to be actually equal to the same exact credits. But if I write, for example, 10,000, 1,050, then it's going to work, but this is not the thing I want, right? The maximum credit can change. Then in this case, I need to use a subquery. So subquery is any query that I write in the parentheses, which is going to return just one value or a bunch of values. In this case, we would like to be able to find this 1050 value with a subquery, and we actually did it, right? What we did was we selected the maximum of the credits from the user table. So this time I'm going to highlight this portion only, my subquery, and if I run it, I see that it returns just one value, which is the maximum credit. And if I run the whole thing, then it is going to first run the subquery and replace it with the value of the subquery, and then it's going to be the thing that I want. It's going to return the name, surname, and credits of the user who has the maximum amount of credits. So this is one thing that people do mistakes about. So the functions cannot directly appear as a where condition. If you need to use the result of a function, then you need to include it in a subquery. So this is actually one thing important. So any questions or problems about this one? So in the slide as well, we have some notes about this one. Just be careful. The functions cannot be directly used as a where condition. If I need to get the value, then I need to include it using a subquery. So for example, let's also find the user with the minimum credits. Then I just need to replace this function name, right? Instead of using the max function for the credit, I just use the min function and get the minimum value. Another example, we can combine different criteria, find name, date of birth, and credit of the users who have more credits than the average. So that's one condition. For that condition, what I did was, so this time I'm not getting the minimum, I'm getting the average of the credit, and I want the value to be not exactly equal. This time I want the credit to be larger than this value. So these users will have more credit than the average. And I have another condition. So this condition is saying, and at the same time, this user should be born before this given date. So I need to have my criteria and use the AND keyword to combine these different criteria. So this time the query is asking find name, surname, and company name of users that are partners of companies. So going back to here, we had 3 different tables. So let's get some more information about them. So from the company table, if I print everything, then it's going to appear that we have the company names, and for each of these companies, we have some monthly payments. And if we look at the partner of table, actually in the partner of table, we are matching users with companies. So users are becoming partners of some companies, and remember, in this table the primary key is user ID and company ID together. This is actually a many-to-many relationship, and if I look at the values, I see that for the user ID individually I have duplicate values. For the company ID individually, I see that there are duplicate values, but the combination of user ID plus company ID are unique. For example, in here, if I try to enter 11 again, it is going to give me an error saying that this creates a duplicate primary key. You cannot insert that value. So this time I'm interested in looking information about multiple tables together. So the user's name is in the user table and the company's name is in the company table. So partner of table is used for matching users with companies through their IDs, through their primary keys. And in this table, these are called foreign keys, right? And I would like to, let's say, show the name of the user next to the company name that this user is a partner of. In this case, actually, I need to get multiple tables. So I need the user table, I need the partner of table, and I need the company table. But if you try to run it directly like that, it's going to be not making a join operation. So let's actually first start with two tables and see what it does. So let's say I have the partner of table and the company table here. If I run it, if I run it, I will see that for some entries, it's going to start with the first entry in the partner of table. So the first entry in the partner of table is actually matched with all the companies. So there are 10 companies. For 10 of these companies, I see these values. And then for the second entry of the partner of table, which is 1, 2, it is matched with all companies. Actually, what we get is a Cartesian product, a cross product between these two tables. And I didn't include all three of them because it's going to return loss of results. It's not going to make the join operation. So one other thing, if I were to include the same table multiple times, company, so the problem is there's going to be some ambiguous columns because they are actually the same table. I need to give them names, right? C1 and C2, for example. Then I can do this operation. Then I will see that, okay, the first company is matched with all other companies, including itself. The second company is matched with all companies, etc. To make the join operation, I need to specify the join conditions. So that's very crucial. We are going to do it lots of times, but first let's give a 10 minutes break. If you have any questions or problems, you can ask. Otherwise, let's give a 10 minutes break now. Any questions before we start? So one important thing is when we include multiple tables, if we would like to do the join operation, we need to specify the join conditions. Otherwise, it is going to do a Cartesian product for the tables. So we were looking at for example, the user table and the partner of table, let's say. If I include these two tables together, then it is going to make a Cartesian product, meaning that every existing user is going to appear next to every existing partner of entry. So it is going to match the first entry in the user table with all entries in the partner of table. It's going to match the second entry in the user table with all entries of the partner of table, etc. If I include three different tables, it makes a Cartesian product between those three different tables. So if I would like to make the join operation, then I need to specify the join conditions. And the join conditions are going to be our foreign keys, right? If I look, for example, in the partner of table, I have user ID column. And for the entries that are matching for the ID of the user table and the user ID in the partner of table, if these two are matching, then I'm looking at a correct line, right? In the partner of table, I say user ID is matched with, for example, company CID 1, company ID 1, user ID 1 is matched with company ID 2, etc. And if I make a Cartesian product with the user table, then I'm matching every existing user with the entries of the partner of table. If I'm just looking at the matching ones for ID and user ID, then I'm actually making the join operation. So if I, as a var condition here, say that I want ID to be equal to the user ID, then this is going to actually make our join operation. So in here, every time in the partner of table, whenever we see some user ID on the other side for the user table, we see that related user, they are matched through their IDs. So for example, in here, I'm saying user ID 20 is a partner of the company ID 8, and in here I have the information for this user with ID 20. So I don't need to project everything, right? I can for example, get the name of the user, the surname of the user, for example, and maybe the company ID in this table. So that's one thing I can do. But I would like to get the company's name as well. Then I need to also include the company table, because company name, if you look, is an attribute in the company table, and it's not in any other table. I need to make the join operation with the partner of to the company table, and let's include the company table as well. If I run it as it is now, it's going to make the Cartesian product again, but this time I'm not projecting anything from the company table. So I'm only seeing from the user of and partner of tables. So I'm getting or projecting the attributes from these two tables. I'm not projecting anything from the company table. Therefore, actually for each of the matching values, the same thing will be repeated. So William Ramirez, I see the company ID with duplicate values. To get something from the company table as well, let's also project CID. If I get the CID, I will see that it is making actually the Cartesian product, this time between these two tables and the company table. And for making a join operation between partner of and company tables, I need to include another join condition, right? I want this condition to be true, and at the same time, for joining the company with the partner of table, I need another condition, which is company ID should be equal to CID. So I'm going to write company ID is equal to CID, and if I run this time, now I'm getting only the join values, right? For the from the Cartesian product of all these three tables, I get the ones where ID and user ID is matching. So these are the foreign key from the partner of table and the primary key from the user table. And at the same time, the company ID is going to match with CID. And these are this is the company ID is the foreign key in the partner of table, and CID is the primary key in the company table. Then I'm making the join operation. And this time, instead of getting any of these values, I can get the company name and project the company name along with the name of the user and the surname of the user. So this is one crucial part. If I include multiple tables, I have to specify the join condition if I want to make a join operation. Otherwise, it makes a Cartesian product or a cross product. One other thing, so in this database, you might see that for the foreign keys and the primary key values that are referencing, we are using different names. So we have company ID referring to CID. We have user ID referring to ID in the user table. And most of the time, we see that the same names can be also used for these matching attributes. And if I have multiple attributes with the same name, I need to specify which table this value is coming from. So for example, if I write user.name, then this means that from the user table, get the name attributes. Actually, if I write a comma here and start typing, so for example, I can start typing company dot, and after the dot, it actually lists the possible attributes to project. So from the company table, I can get the CID, for example. If you have multiple attributes with the same name, then you have to specify which table it is coming from. Otherwise, you have problem. Otherwise, it's going to say that this attribute name is ambiguous because I'm not sure which table it should come from. There are multiple tables that includes this attribute name. But in this example, there are no such attributes. So to write it shorter, so for example, for your SQL queries to be shorter, you can use different names for each of these matching values. But to remember them better, actually using the same name makes sense. Then your query would be a little longer because you need to specify which table these are coming from. And this can be in the projection, for example, and this can also be happening in any of your conditions. So from the user, get the attribute ID, and this should be equal to the user ID that's coming from the partner of table, and from the partner of table there is the company ID, and this is going to be equal to company's CID. So for all of these, actually, I can specify which table they are coming from, and this is going to be actually the exactly same query. So I included the CID as an additional thing. I can get rid of it. So this is an equivalent thing. We can give names to our tables. So for example, for the user table, I can give the name U to that table. Then this time, the user table that I introduce is going to be called U. There is no user in this case. I need to replace them with U characters, or this can be any name, U1, etc. For example, for the partner of, I can use PO, then it will be shorter. And for the company, I can give the name C to the company table. Then I can refer to the company table using this new name. So this is just giving name to the tables. And we can do it for the attributes as well. But to give a name to the attributes, so for example, in here, for the U name, this attributes, I can name the column as some given value. For example, in here I can say username, for example. If I run it like this, you will see that the column name is changed. So the column's name becomes username. if I want to have the space character in here, let me try. I can include the single quotations. So this time the column name has the empty character in it as well. So this is giving name to attributes, and this one is giving names to the tables. And this is like similar to what you have in relational algebra. So you have the rename symbol to give a name to some relational algebra expression. So this is one example that makes the join operation. If we include multiple tables, it makes the Cartesian product. And we actually, if the names of the attributes are unique, if the same name of the attribute does not appear in any of the tables that we include, then we can just directly write the attribute name. Otherwise, we have to specify the name of the table where this attribute comes from. So this is one example. Find username, company name, credit and monthly payment of the users that are partners of a company and have at least 500 credits. So these two conditions are for joining the tables. So I need to join each let's say tuple of tables. So if I include 3 tables, if I would like to join all of them, so for joining the user table with the partner of table, I need one join condition in between. So this is that join condition, and to join partner of table with the company table, I need another join condition. So this is that join condition. They should be true at the same time. So I have the AND keyword here, and I have another criteria saying okay, these users should have at least 500 credits, and that's another criteria that we include here. So this is another example. We may say that, okay, find name and credit of the users that live in the same city as a user named Brandon. So we would like to find name and credits. So let's come back to here. Let's get name and credit. Let's also get the city from the user table. And for these users, our condition is saying that we should be in the same city as Brandon. So the city should be equal to Brandon's city, which is actually currently Istanbul. We can directly write Istanbul, but this is not doing the what we require, right? Brandon's city may change. Maybe we don't know Brandon's city. So we need a subquery to find Brandon's city in this part. So this is going to be a subquery. We are going to select the city from the user table. And for this user, actually, our requirement says that the name should be equal to Brandon. So the name of this user should be Brandon. Find that user, and for that user, get the city. And we are looking which other users are in the same city. So let's check what is the problem. So we forgot to write where here. The keyword was missing. So if I include the keyword here, now I see, okay, these 3 users are living in the same city as Brandon, and Brandon is also among these users. In here, there could be one problem. So let me showcase that. In the user table, currently we have just one Brandon, so there is no problem. But let's rename Paula as Brandon as well. So let's say we have 2 Brandons. Remember, when I change something in the database, I have to commit. Otherwise, the settings or the changes are not saved. Then my query cannot find or see that new value. But this time I have 2 Brandons. One is in Izmir, one is in Istanbul. Let me go back to my query. This time this subquery. So I'm going to first run this subquery. So the highlighted portion returns Izmir and Istanbul. This is not single value, right? This is multiple values. So if I run the whole query, then it is going to only do it for the first instance. So if you use the equal symbol, for a set of values, it's going to not do it for all of them. It's going to do it for the first instance. If I'm interested in the being equal to a set of values, I need to use the keyword in. So if I run this time, it works correctly, right? There are two Brandons, one in Izmir, one in Istanbul, and for these two cities, this is the list of other users that are living in these cities. So let me do it reverted. So if I use the equal symbol for a set of values, it's going to fail. So if the subquery is going to return more than one value, and I require it to be within that set, for example, this is going to return a bunch of cities, and the city that I'm looking for should be in this set, then I'm going to use the in keyword. So that's one thing to be careful. And this query, for this query, we can actually, if you remember from relational algebra, there are such questions, right? Find the users with non-equal cities, with the equal names, etc. We can use Cartesian product for this one. So let's do it using the Cartesian product. We can get the user table twice. So the first user table is called U1. The second is going to be called U2. If I project this information, then it's going to be, if I omit which table it is coming from, this time it is going to be for the first instance. So for U1, this is the name. If I want to get the U2's name, then I need to write U2 specifically there. So let's for now just get the U1 side. So these values are actually coming from U1 side. And to be sure, it is better to include it. And for the tables with the or the different instances of the same table, if you omit the name, it's actually using the first instance for projection. But for var conditions, you have to specify the name. So let me include a var condition here. So let's say the name should be equal to Brandon. So if this is my query, then this is going to give an error. It says ambiguous column name for name. So you wrote name here. Which table this name should come from, I don't know, because in the U1 table and in the U2 instance of the same table, so these are the same table but different instances, so they are actually treated as different tables. In U1 there is the name attribute, in U2 there is the name attribute. Which name attribute you are referring to? I'm not sure. It says ambiguous column name in that. In the projection, if I omit the column name, it is using the first instance, but for other places, for example for var conditions, we have to specify the name of that column. For example, I can say, okay, U2.name should be Brandon. So I have two users. I set U2 to Brandon, but at the same time I want U1's city information to be equal to U2.city. So U2's name is going to be Brandon, and for that Brandon we get the city information, and from the U1 side we include that city information, and while projecting the values I get the ones from U1 side. So if I do this query, it is again doing as we did before. It is showing the users that live in the same city as the users named Brandon. But if I don't want to see Brandon here again, I can put another condition. I can say that, okay, U1's ID, this ID actually should be different than U2's ID. So these actually should be different users. Then this is not going to show for Brandon's. This is going to show only the other users. Any questions or problems about this one? Then we go into group by. So another important topic, if you are careful, it's actually easy, but you need to be careful about some points. So group by is going to group your entries together based on a bunch of attributes or just one attribute. So let's do it with an example. From the user table, let's select the, for now, let's select the name and the status from the user table. You see that the status information can be full, half, or quarter. So this is some information about this user. It can get 3 different values. Let's say I would like to group these users according to status. So the group by is the keyword to do that. There's this space character within it as well. So I would like to group the users according to status. So one thing to be careful, this actually makes the groups, but within a group, multiple entries are together. And because of that, in SQL it doesn't give an error, but in most of other variations of SQL, for example in MySQL, this query will give us an error. The problem is that we are grouping according to some attributes, and we are trying to project some attribute that is not included in our group by statement. So this is one important point. So we are going to select project some attributes plus functions, and let's say we are using the group by according to some other attribute list too. When using this group by, the things that I project should be a subset of the things that I group by. Otherwise, it doesn't make sense. In SQLite, it projects something, but for a group. So for example, let me remove the group by statement. You will see that there are lots of users with full status. So William is a different user, Brandon is a different user, they both have the full status, Wayne is another such user. If I include this group by status, and if I try to project the name as well, within a group there are multiple users, and actually William here does not make any sense. It is just the first instance within that group. And most of the time when I'm using the group by keyword, I'm actually not looking for individuals, I'm looking them as a group. So if I follow this, I can only project a subset of the things that I group by. So in here I just group by one value, then I can project that. I can project status. Okay, I have, if I group according to status, I have three different groups. The groups that have status full, the group that has status half, and the group that has status quarter. These are 3 different groups. But the group by keywords actually also allows you to use functions for the groups. So I can project the things that I group by plus functions, the results of functions. So that's actually going to be where we mostly use the group by statements. For example, I can print the count for each group. Then it's going to be within that group how many entries that I have. So in the full group I have 8 users, for the half group I have 7 users, for quarter I have 5, and this is going to add up to 20, which is the number of users that we have. And for this count I can give a name as well. For example, I can say, okay, this is the number of people, for example. Then it's going to rename the name of that column. And for example, if I'm using it in a subquery, I can easily refer to this value using the column name. For example, within each group, I can say, what is the average credit? So that's some other function that I can use. So the functions can use any attribute name, but if I'm projecting like single attributes, then it has to be a subset of the things that I group by. So for example, within that group, the group with the full status has this average credit, this one has this average credit, etc. I can use any existing function with any of the column names. Any questions or problems about this one? So this is one of the important concepts. One additional thing, I can group by multiple things, right? But if I'm including here, for example, if I include name is mostly unique, right? Then there are going to be actually lots of different groups. So I see full. If I also include the name as our projection, then I see that, okay, this is very small group with Brandon. So actually for each of these groups, we have just one person, right? For an attribute to make sense when you group by, it should have some common values for different entries. So that's some other thing that we need to be careful about. So for example, so this is actually saying what I said. So in SQL, this is not giving a syntax error, but in some other variants, it gives a syntax error. And because of that, we would like to follow this constraint in the homework and exams. And actually in the SQL lit as well, it doesn't give an error, but it doesn't make much sense because, for example, one individual from that group is not a representative of that group actually. While using the group by statement, we are actually inspecting something else. We are looking at information about groups, for example. So this is another example. Find the number of partner users per company. Display the results along with the company name. So this time I'm interested in how many users in each company, right? Find the number of partner users per company. And this is going to include the partner of table first. So let's start with a more basic one. So we are going to group them according to company ID. If we group the entries of the partner of table according to the company ID, then if I'm projecting the company ID here, so this is going to be like the most basic form, I see the distinct company IDs that users are partners of. And if I would like to display some information about them, for example, how many of them exist, I can show the count, right? For company ID 1, it's matched with 4 users. Company ID 2 is matched with 2 users, meaning that in company, for company ID 2, there are 2 partners. For company ID 3, there are 3 partners, etc. So in the relationship, I can group them according to some attributes. And one other thing is also important. In here, I'm not writing user ID, because if I were to look at from the user side, then if I'm grouping according to the user, then I'm looking at how many companies each user is a partner of. For example, user 1 is the partner of 3 different companies. But for example, user number 3 is just the partner of 1 company, etc. So we are looking at it from the company side. That's why we group by the company ID. But instead of showing the company ID here, we would like to show the name of the company. So the name of the company is actually included in the company table. So I need to somehow get the company table here. So if I just included it, so here let me write it like company name. If I just included it, it is going to make the Cartesian product. Remember, we need to specify the join conditions. So where from the partner of side I have company ID, this should be equal to the CID from the company table. So if I run it like this, it is going to this time display the company name, but we are not following this constraint, right? If I'm using group by, so here I'm using group by, then I can only project company ID plus functions. And company name is actually not among the things that I group by. One option to make it follow the condition. So for this specific example, the SQLite version returns the correct result, right? Because we do not have multiple companies that share the same name. So that's why it's actually working. But in here, one thing that we can do to follow that constraint is to include the company name as well. So if you include company name next to group by, it's not going to make any difference, but it is going to also follow this constraint. The things that I project as single attributes are a subset of the things that I group by, plus I have a function here. So this is correct in all SQL variants. So in MySQL as well, this is also going to be correct. So this is one way of doing it. So coming back to here, so this was one way of doing it, and another way is actually using subqueries. So these two are both correct, but this is kind of a longer way, and let's also do it like this. So in this version, what we are doing is we are creating a subquery, and we are giving a name to this subquery where we join different tables. So actually, let me write it from scratch. So let's say I have the company table here, and in here I would like to get the company name together with the number of users within that company, and this is the place that I make the grouping. I would like to group according to the company ID. So this is valid, but the company ID is not in this table. So for that, I'm actually going to introduce another table. So another table can be directly the name of that table, or I can use a subquery to get a result set, right? And a result set is actually very similar to a table. So I'm going to say, okay, I'm going to get some result set from here. Let's call it maybe for table T. So this is going to be treated as a table. I'm giving a name to that table, and in that table I would like to do the join operation. So this is going to be, for example, let's select the company name, and also let's get the company ID from the partner of and the company tables. So let me actually go to new lines for this. So the indentation is as well for us to better see it, otherwise it doesn't make any difference for the code. So in here I would like to join these two tables. CID from the company should be equal to the company ID from the partner of table. So this subquery, why I include that? Because the company name and company ID are in two different tables. I make the join operation in my subquery, and in here I call this T, and then in here I can actually specify some join conditions. So for this question I don't need to do it like this, but I'm doing it to show an example of it. I can in here say the company ID of this table, so it is one of the values that I project, I can include it in here. This is going to be equal to the, so in here I just have the company table, right? Because of that I have access to CID. This is going to be equal to CID. That's another thing I can say. And in here, so if I go back, if you look at here, actually we would like to do the grouping, we would like to actually do the grouping in the subquery, right? In the outer part we don't want to use any grouping because we would like to just get the values and project them. So in here, I'm going to group them according to company ID. Actually, because of that, I don't need to get the company table here. So let me go back. So I'm just looking at the partner of table as we did at the start, and within the company table I group them according to company ID, and in here I'm going to project the company ID, if I can write it correctly, and also the number of people in that company, and I'm going to give a name because I would like to be able to refer to the result of the function. So number of people, for example, number of partners, or maybe. So within the subquery, what I'm doing, let's just run this highlighted section. I'm making the groups, and for each group I'm showing the number of partners. For company ID 1 I have 4 partners, for example. For company ID 2 I have 2 partners, etc. And then I would like to join this with the company table because I would like to get the company name as well. So I include the company table. This is my other table, and in here my condition is saying, okay, from the T side company ID, this should be equal to the C ID of my company. That's my var condition, and in here, instead of using a function, next to the company name I'm going to project the number of partners this time. So if I run it like that, then it also includes the company names here. So this is actually some alternative way of doing it. Just know this. But for grouping, for group by, this is the easier way to follow the format. So this is actually, sorry, does it include that one? So in this version, it says if company name is unique, we can use this query, right? So let me do it to show the difference. So this is my query, and it is going to work if the company name is unique, because we just group according to the company name. We make the join operation. In here we actually don't need to include the user table as well, because we are not dealing with individual information about a user. If the company name is unique, we have these companies. But let me go to the company table. For example, let's look at the data. We have Nemo Star. Let's say we have Nemo Star twice. So I'm going to commit the changes. We have Nemo Star twice. If I go back to that query, this one. So this was previous results, right? Nemo Star has 4 members in it. But if I run it now, Nemo Star suddenly has 6 members in it, because there are actually 2 different companies that share the same name. While making the group by operation, we actually need to group according to the unique entries for such examples. So I need to group according to the company ID as well. So if I include company ID here, then it is going to first group according to company ID and then according to company name. We will see 2 different instances of Nemo Star as separate entries in this example. Then.
Can I ask a question?
Yeah, sure.
What happens if we don't include the company name in group by? Just group by company ID.
Okay. In this version, in SQLite, it works. But there is this condition in other SQL variants saying that the things that I group by, the things I project should be a subset of the things that I group by. If I write it like that, company name is not included in the things that I group by. Therefore, because of that rule, I cannot project this attribute in those other SQL variants. So that's just the difference for that one.
Okay.
In just SQLite it works, but since most of the variants does not allow that, we want you to follow that constraint in the homeworks and exams as well. So that's why we include the company name, because to make this possible projection attribute set larger. So let's come back to here. So this is again saying that thing. So another question, find CID of groups with more than 2 partners. When we make groups, we can put conditions for the groups, and to do that we are using the having keyword. So that's another keyword, and this makes this is used for making comparison, but for the groups, and most of the time we are going to use functions for that. So we are this time find CID of groups with more than 2 partners. So since we are just using the IDs, actually again we can just look at the partner of table, so that will be enough. So in the partner of table, if I group according to company ID, then I can project, for example, company ID and the number of members in a group. And this time we would like to look at the group and find which groups has more than 2 members in it. One way you may think, okay, maybe I can use the var keyword, but remember, if you are using the var keyword, then you cannot use a function. So if you try this one, it is going to give an error saying that in the aggregate function count you are using it in a wrong place, misuse of aggregate count function. So I cannot use functions next to var statements, but I can use functions next to the having keyword. Having is going to look at the groups, and for example, if for a group the count is larger than 2, then it's going to include that. So without the having keyword, so let me get rid of it first. This is the results. So for each of the company IDs, I see the number of members that are partner of that company. But if I include this constraint, this is going to be a constraint for the groups. So for each group, the count is going to be larger than 2. One other thing, next to having, this time it doesn't make sense to refer to attributes. For example, in here I can say, okay, for this members, for this group, credit should be larger than 100, but then it's going to give another error. Okay, credit is not included here, that's why we have the error. But for example, let's say company ID should be larger than 5 for this condition. It's going to work, but not make much sense, right? For a group, if you are inspecting some information about a group, then you better look at the individuals. So actually not the company ID, but if I write user ID here, it will not make sense. Okay. So for example, in here I'm saying user ID should be larger than 5, but such information about individuals should be appearing next to the var statements. So that's what I'm actually trying to say. So next to var, I can look at individuals. So user ID larger than 5, it is some information about a user, about an individual user. And if you realize, the results are different, because in the other case, for a group to have user ID larger than 5, it doesn't make much sense. It actually looks at the first instance of user within that group. So for example, if my var statement was saying that, okay, the user ID should be larger than 19, there are actually 20 users in our database. So this is going to get the results only for a limited number of companies. For example, user ID 12 is the partner of these 3 companies, and these 3 companies appear here because of that. But if I were to include this using the having keyword, having user ID larger than 19, it is going to return a different result, because this time it's actually looking as a group. And for a company, if the first instance has user ID that is smaller than 19 or equal to 19, then it is not going to return such values. So just be careful with the usage of having. If I'm using having, then I expect some function here. For example, I can say average. So if I include here, for example, the user table as well, and if I join these two tables together, the condition was ID of the user to be equal to user ID from the partner of table. And I can say, okay, average of the credits within that group should be higher than some value, for example. Then I'm inspecting this. So I list each company's IDs and within that company how many users there are, but only for the companies that has average credits. So these are the partners of those companies. So some company could have multiple partners, and among those partners I look at the average credit. Why? Because I group according to company ID. I was making the join operation already. If I group them according to company IDs, within a group I have people that are partners of that company, and for those group of people I look at the average credit. For example, if I make it a higher value, then I only see 3 different companies. So for example, in company number 10 there are 4 different users, and average credit of those 4 users are strictly larger than 400. So that's what we get from this query. So we can mix and match these conditions with where statements. With where conditions we are looking at individuals, with having we are looking at groups. Because of that, next to having we should use functions. Otherwise, for a group, a single attribute cannot be a representative, right? Within a group we have, for example, lots of different users. Which users credit we are going to look at. So some queries can update values in our tables. So update queries, insertion and deletion queries are in those kind of queries. With update queries we start with the update keyword followed by a single table name. So updates a single table. We update a single table at a time. Then we have the set keyword. Set means that we are going to set some attributes. That attribute is going to be equal to some value. We can just directly write the value there. For example, we can say that, okay, set all users credit to 100, for example. In that case, I can say credit equals to 100. We can put conditions still. So I can say, okay, I would like to only update the credit of the users that live in Ankara or Istanbul. And that's going to be according to the credit of the user, for example. Let's come back to here. For example, let's write an example query, update users. We would like to set the users, for example, credit to be equal to something. And that value, let's say, we would like to increase users credit by the amount of the ID of the user, which is not very meaningful, but we can do it. This is some attribute, this is some attribute for an individual, and it's going to work for each of those individuals. So if I run this query, so I highlighted by mistake, now I run the whole query. It says query finished. There are 20 rows affected by this query. It is not showing anything, it is not projecting anything because it's not a projection query, it's an update query. But if I go to the user table and look at the data, and if this was already open, I may need to refresh the tables. But I will see that, for example, William, because William's ID is 1, the credit amount is now 301, for example. And if I were to run this query multiple times, a second time, it's going to do the same operation again. For example, if I come back, now William has 302, for example. So we can put the conditions just as we do with other types of queries. We can, for example, say where only for the users with ID larger than 10, for example. This time it will affect 10 individuals. So this is some other query. So in here we increase each user's credit by the monthly payments of the companies that this user is a partner of. If the user is a partner of multiple companies, then he or she will be paid multiple times. So in this case, actually, we would like to get some number here. We would like to increase the credits by some value. And that value is actually going to be acquired by a subquery. So in here, what we just want to do for the users that are partners of some companies, we would like to find the sum of monthly payments for that company. And in here, we are going to use a subquery. Like coming back to here, what we would like to get is the sum of monthly payments. And this information, so this is the thing that we select, this thing that we project, is going to come from, this information is in the company table, right? From company. So this is going to come from the company table. But is it enough? In here we just have the company information, but we would like to relate it to a user. Because of that, we need to also include the partner of table. So we get the partner of table as well. And remember, we would like to join these two tables. So CID from the company should be equal to company ID from the partner of table. So these are the things that we do. But we would like to also relate this subquery to the user, to the individual user that we are updating. So to do that, instead of introducing another user table within the subquery, what I'm going to do is to refer to the user table that's outside my subquery. So in a subquery, we can introduce new tables, and one other option is to use an existing table outside my subquery. So this is my subquery. I would like to use the user table that's outside my subquery. I can directly do that. I can write here user.id, for example, the ID of the user that's outside my subquery. It should be equal to the user ID within the partner of table. So that's one thing that I can do. And then if I try to run this, it's going to say not null constraint failed for user credits, because not every user is a partner of a company. For some users that are not partners of any companies, this query is going to return null, right? So the outer query, so if I write 10 here directly, this is going to work for every existing user, but not all users are partners of companies. Because of that, when I get some information about the monthly payments, it may return null values for some of the partners. To avoid that, in this outer query, I will include another condition and say that, okay, for these users should appear in the partner of table. So this is going to be actually our condition. So our users ID, user.id, actually I don't need to write user as well. This ID of the user should be included in the user IDs within the partner of table. Then so let me just run this subquery. This subquery returns the users that are partners of some companies. For example, in this list, you will not see some of the existing users. Some of the users are not partners of any companies. And for these users, so it says 16 rows are affected. So 16 users are actually partners of some companies. Some of them are going to be partners of multiple companies. And for such users, we are actually calculating the total monthly payments. This subquery depends on the outer query. Because of that, if I highlight this subquery, it's not going to function. It's going to say, okay, I don't know what is user ID, because user ID is actually come from the outer query. So from the outer query, it is running for each individual user, and then for each individual user, each individual's user ID, we are running this subquery. So this is like one more advanced SQL query. Any questions or problems about this one?
Can I ask something?
Yes.
Can we use equal instead of in?
For this
Where
one,
statement, yes. Yes.
okay. In here, if I choose this one and run it, you will see that this subquery actually returns multiple values, right? And if you write equal, then it is going to be only working for the first one. So it is going to only get the user ID 1. It's going to do it only for user number 1. So if I run it, now it says only one row is affected. It only updated one user. So if something is returning a set of results, we have to use the in keyword. Otherwise, it is going to make the equal operation, but only for the first instance of that value set.
Okay, thanks.
No problem. Any other questions, problems? But for increasing the credit number, since we are using the functions results, and we know that the function sum will return just one value, even if this user is a partner of multiple companies, we just sum up the monthly payment values and we just get one value, so we can add it to the credit amount. So this is like a more advanced SQL query, and in the next lab we are going to see more advanced queries with Python as well. And we have the deletion queries, and in deletion it's very similar to update queries. We write delete from the name of the table, then we specify conditions. If you don't specify any condition, then you are deleting actually everything. So be careful with the delete from queries. So we can put any conditions, we can use any var conditions, and we also have the insert queries. The format is very similar to update queries. We write insert into, then the name of the table. With insertion, deletion, and updates, we are looking at one table at a time. We insert into one table, we delete from one table, etc. If we need to insert multiple values, etc., we use multiple SQL queries. For example, in here we are inserting into the user table, then we need to give the values, and the values should have the correct format, right? If it's a text, we need to include the single quotation. If it's a date, we need to again include the single quotation and use this format, month year dash month dash day format. If it's a number, we write it directly. So the order of the values are in the same order of our column names, right? If I look into the user table, I see there is some ordering for the attributes, and while inserting I need to give the same order. But there is another option. We can next to the table name, we can specify the name of the attributes. It can be in different order. Then we need to give the values in this new order. So we can also, if we omit some of the attributes, then we can insert null values for those attributes. But in the user table, if you remember, only city can get null values. The other attributes cannot get null values. So let's come back to here and write some example queries. So insert into the user table, and then we can give the values. And if I'm just writing it like this, then I need to give the values in order, right? For example, this is one valid order. If I copy and paste it, if it pastes correctly, so actually it did not, or yeah, if you are copying something, be careful, the formatting might be not correct when you copy. In this case it was not, so actually writing it from scratch maybe would be easier. So hopefully these are our insertion values. If I run it, it says one row is affected, we just added one row. If I look at into the data section of the user table, I will see this new user inserted. With insertion queries, if I try to run it again, it will fail, because this time it is going to say that unique constraint failed for the user's ID. User's ID is the primary key for this table, and it should be unique. But I'm trying to insert the same value again, which is going to cause a problem. So I need to change this value into 22, for example, then I can add it into the table. So I need to also be careful about the formats. For example, for John, if I give it like this, then it's going to be a problem, because it thinks that John is an attribute name, which is not. It should be included as a string. Any questions or problems about any of these? So in SQL Studio, we actually do not save the queries. So this is a better place for playing with the queries, testing them. If we need to, we can actually in some place save the query, but it's actually in not a very manageable format. So we are actually in here. Okay, so we can save this SQL to a file, but what it does is it's just going to put that text into a text file with an SQL format. We are not actually going to use it like that. But in SQL Studio, we are going to like play with SQL queries or test them, see what we get. And actually, in the next step, we are going to start using Python to connect to our SQL database, and we are going to run SQL queries using Python. And if some version of the Python is installed on your computers, that's going to be fine. If Python is not installed, you can use the Anaconda distribution, which is very easy to set up. So this is going to be required for the project. Other than the project, you don't need to install Python. But if all the group members have Python on their computers, it will be better. But if just some of them have, that's also okay for us. So for the next lab, like if Python is not installed on your computers, it will be good to install some kind of Python on your computers. And if you like did not have any experience with the Python, installing it using the Anaconda installer is very easy to do. Actually, in the lab 4 slides, we have like some information about how to install it as well, if you need to look it up. But like most of you got the Python course before, I guess you use the Spider tool to write Python code, and that will be enough for this course as well. If you don't have any questions, then that's going to be it for today. I guess Semra Hoca will also have some additional lecture today. So if you don't have any questions, that's it for our lab. Okay, see you later.
See you hocam.
Görüşürüz.